So yeah. So the top digital trends of these manufacturing was the data which it the first thing was the data which it collects through the network in between the sensors and devices. So with that data, it simplifies it and it improves the industrial activities also. And the second thing, they have brought up this IoT's application with the two things, which is artificial intelligence and the machine learning. So these two makes advanced of algorithms, and it also analyzes the raw data and or data and it translates into the practical actions. And the third thing on the robotics, which it has a highly cost effective. So these robotics has been working for our factories along with the humans also. So they have invested a lot of cost effectiveness on this because it's gonna get to be operate on a 24/7 and also without any misleadings of work, it's gonna be get to be operated in a very well way and it has an help of efficiency in all the stages. It has an help towards in all the stages even. So the human workers for quite some time along also. So yeah, this is a major advantage of this using of robotics, which is the top trend of digital in a manufacturing. And the last one is a big data and industrial analysis. So analytics, which it is a type of a technology which it enables the manufacturers to be three major things, which is manage, update, and analyze the amount of a digital content which is really happening in between the customer and the product information. So the advantage of this is to it decreases the cost and downtime even. And the other thing was the IoT uses. So it has six of a major, which is a remote production control, predictive maintenance, industrial assist management, digital twins, logistic management, manufacturing KPAs. Okay. Okay. It has a it has a six major things of an users of an robotic manufacturing, which is a remote production control, predictive maintenance, industrial management, digital twins, and the logistic management, manufacturing KPIs. So simple, I'll say roughly the data because we have like yesterday itself I have explained these things. So no, so yeah, and the remote coming to the remote production control. So the main thing of this remote production control is to be a monitor and equipment configuration. Monitoring means you know that the dealing with the from the start to the end of the product, like from the start of a thing until we grid of a thing different. So, and the equipment configuration is nothing but whatever the thing you're maintaining upon any business or in any organization. If you have a aim of something, like if you have a cosmetic of an organization and someone have some other thing of an organization, no? So in that way, that whole process, the equipment in the sense like that is the whole process of a configuration means the everything of an in detail from the start to end is like that. So that gonna process gonna monitoring by this thing, which was a remote production control. So firstly, these employees gonna be have remotely they collect the information from the product processors itself and they check whether the outcome is really specific of a regulations or requirements. So if you are doing some kind of an like business upon one thing, so is to take an example of in a cafe. So if we are really maintaining that cafe, so you have to also check this thing after some time, like while going on process. Okay, fine, it's you're developing in a good great way, but also you have to check whether you're getting an incomes of benefits or a profits or have to see whether everything was going on your rule and regulations and requirements or not, right? So in that way. So to the employees, it remotely collect the information on the production processes. Means in this they are saying that you're joined in something and they're seeing your processes and they're checking whether the outcome is really having and to meet to be some specific regulations and requirements or not. Okay. The second thing was they can configure it that the device is going to be remotely significantly saving the time and effort. So yeah, coming to that like that only same thing. Here the thing was saving a time and effort. So the other thing was the automated devices, which it allows the employees to fix performance issues on virtual networks. Okay. Okay. Moreover, coming to the remote production control, it doesn't require any human interaction or any human to machine interaction. So if you got any of a thing which in issues of performances or on any issues of regarding it, for the work and the application, so it's going to be implemented the work. Sorry, it's going to implement the glitch whatever it has occurred very fluently without any permissions and etc things. So in our words, basic words, we're gonna say that it is an automatic of an processes. So in that way, like that's just like I have said, right? So there's the streaming, the management, and the control of equipment. So there doesn't require any permissions to be to rectify some issues of the performances. So it's gonna fix as immediately, like the word like an automatically. Shortly, can you say that? And the thing was, the next thing was virtual equipment monitoring is also allows the employees to aware that device location. You know, right? Uh, like everyone, we have generally we use a GPS, right? The location tracking, which is in a software application only. So in that way, also here the employees gonna be get often aware of that device location, including the mobile aspects also. So next thing was and the last thing was these software gonna be kept track the power consumption as even just like a device location. Okay. And the next thing is all about remote control. That's sorry, remote production control. It is all of the monitoring and equipment reconfiguration itself. And second thing was predictive maintenance. And the next thing is predictive maintenance. In this, there is completely no offer human human participation. So to comment to this, it doesn't have any human interaction. Guys, with this big video, Okay. And the next point is these embedded IoT sensors can get or detect some malfunctions regarding the things which is mainly it detects the temperature, running number, pressure, voltage, etc. Okay. These things is gonna sensor and they gonna be get detected as operation with the malfunctions even. So, and the next thing was it's gonna alert some personnel of equipment and violation of an employees to take some like steps to be remediation. Another thing was it is also called by two things, which is predictive maintenance and predictive repairing. So these two things allows that the technical service teams to be get detect issues and result is yeah. Let me explain a simple way this one point. It is that so this predictive maintenance and predictive repairing are like or a predictive repairing. Okay, these work of this is to that to fix the problem before it get to be bigger of time. Okay, if it the problem is getting in a starting stage, then it's going to be rectified very fastly and automatically. So without making of a series of an equipment failure, then it's going to fix down by reducing the time and the cost. Okay, it is all about the predictive maintenance or predictive repairing. Okay. And the next thing was predictive maintenance also has some kind of it allows for integration of an IoT connected device with advanced and elastic software to anticipate when that technical support service is needed. Okay, so the wherever the IoT connections has been connected the devices with that advanced things of application. So it's gonna be also get to be need if they need any technical support, it's gonna be get to be needed as soonly also. It all about predictive maintenance. All about it is all about there is no interaction of human in this. So in this, this mission is going to get to be detected some for operational malfunctions, which is temperature, turning number, pressure, voltage, etc. So So yeah, the next thing was industrial system management. So it is all about a real-time information of a monitoring with an assets of on a web or in a mobile applications. The basic aim of this is to attract assist the three things, which is mainly the first thing was vehicles delivering raw materials or produced of a goods. The second thing was items in warehouses. The third thing was resources during the production processes. Basically, they gonna track these things and they will they're gonna optimize these assets of one of all manufacturing stages. Sorry, stages from the supply chain to the end product delivery. So the proper monitoring has to be done, which it enables the quick and efficient of identification of issues, which it impacts the product quality or to be on or also time to be on a market. So the industrial assist management is all about the tracking of an assets, or it not only with the monitoring. This monitoring process gonna be done only with the real time information like on spot in your language. So yeah. So these vehicles gonna deliver the raw materials, which is or also produced whatever the goods and services. And the second thing was the items gonna be to the warehouses, which is simply we're gonna say inventory management. And the third thing was the resources offered during the production processes. So these three things is gonna be optimized, the tracking and etc. stuff. And the next thing was a digital twins. So coming to the digital twins, it is of a three major ones, which is artificial intelligence, machine learning, and the cloud computing. So these digital twin technology is based upon Internet of Things. The digital twins are also to be virtual copies of physical objects only by some kind of an applications or manufacturing, which is to be very useful. Yeah. So and the next thing was this virtual copies gonna have an equipment and gonna have some spare parts where that engineering and managers gonna be stimulate some processor and they're gonna conduct with that spare parts some kind of an experiments and they're gonna discover some issues and HU needs to be of an results without of taking any risking or damaging risking or damaging of any physical assets. So these digital twinning is gaining much of a popularity, where the IDC stated that companies gonna invest in the digital twins in the year they has been done in the year of 2018. They have expected some kind of an improvement in or within a critical issue problems, so critical processes. So by applying this IoT approach, these businesses are gonna get reboots of digital copies, virtual copies of a physical objects even, and their application gonna be on a manufacturing floor gonna be a bit handy. Yeah, this digital twins technology has been so this has some the technology is based upon the three major things, which is artificial intelligence, machine learning, and one thing was the cloud computing. So where the coming to the cloud computing, it stores the data. Machine learning algorithms and artificial intelligence of an application, they're gonna make the work which could be get a little smarter way. So that virtual copies of equipment with that spare parts, they're gonna use engineers going to stimulate some kind of experiments to whether to get rid of results without any. a risking or a damage of a physical asset. I think the thing was logistic issues management. Logistic management, it is a part of different transportation. In the logistic, transportation plays a major part. So it really wanna feel the risk when they having weather issues. So, but also it has some fraud and the large amount of assets which need to be get managed these companies. So that depend upon significantly and a transportation. It's going to be get a concept of an interconnection in between the various devices and the systems. So they're going to deal with many use cases along the typical supply chain, either from the warehouses to fleet management to cargo tracking, etc. You know the cargo tracking, right? So it is all about just like that only. So these acts as a ritual process of a digital transformation. So like, yeah, behind digital transformation. And the next thing was gonna also replace that fuel and etc. things of an expenditure because it has to be get the one location to another location, right? The transportation itself, so that way they have some safety and etc. advantages also till the work ends. Manufacturing KPIs. Wait a minute. The manufacturing KPIs include one of the processing, which was overall equipment efficiency. So with that, they're gonna check the whether they're gonna measure the calculations of the performance of the factories. It's like the availability, the quality, and etc. things. That is the work of a KPIs. So it is all about the understanding of a performance from a uh, diverse of a perspectives. So not only for a KPI, so many were using this OEE, which is going to save like overall equipment efficiency, efficiency. It is a data which is simplified the reports and dashboards that going to be get further how the well the business is really performing. So next thing was automation of an IoT, the one of an application. So these industrial automation has an application of various control systems, the computers and IT. So for the managing for some kind of different processes, this necessary has been industrial to the replacement of a human involvement density, and this has a huge offer like usage of technology to perform such tasks that would be in otherwise the entire human labor. So the industrial automation is implemented by using the various technologies, it's like programmable logic controls, industrial of the PCS and CADA systems, and more recently of an IoT. More recent of an IoT. These include some programmable logistic controls and industrial systems and etc. So let's go to some more deeper. So yeah, basically these are the different processes and mission industries to replace a human involvement. So there are so many ways that how this IoT integrates into the automation. So there were some ways which is real-time data collection and data analysis and the insights and also the process automation and optimization, monitoring and control and predictive maintenance. Let's go into the detail. What was that? So coming to the real-time data collection. So these IoT devices has such as sensors and smart machines which can collect the amount of the data in real time from the various points in industrial processes. And yeah, the real-time data collection is all about it is all about the sensors and the smart machines which can get a control or sorry, which can collect the amount of a data in a real time from the various forms of industrial processes. But coming to in our life of an actually we use a smartphone, smart watches to the collect the data on real time, like we get a real data, right? Whatever the health, the readings, whatever the health we really get. So in that way, is one of the examples. Next thing was the data analysis and the insights. So these data has been collected by the IoT devices, which is to be sent to a central system where it is analyzed to deserve a meaningful insights. And advanced machine learning algorithms has can be identify some patterns, trends, and on analysis. And these further used to optimize the process to predict the equipment solution and identify bad bottlenecks in production. Data analysis and insights. So these data is being collected by the IoT devices, which is sent to be a central system. Okay. So by where it has been wherever it has been analyzed to be a meaningful insights. So whatever it has been analyzed, so with it's gonna be good with an advanced for machine learning algorithms only. Like machine learning algorithms gonna be we can detect with that algorithms the patterns and the trends and etc. things, right? So it has been used for the further optimized process even. So to predict an equipment of a failures or to identify the bottlenecks in a production. The next thing was a process automation and optimization. So in this coming to that, it is derived of some kind of a data which it can be used to for an industrial purposes to optimize the like whatever automation is the name is saying that it is saying that the work going to be done automatically, right? It's like an example. If we take the sensor, so it's going to detect some kind of a drop of efficiency of an emission and can also be getting a trigger on an automatic response to address the issue. And just like that only, parameters are scheduling it for maintenance even. And next thing was actually controlling, monitoring and controlling processes. So these allows that to remote monitoring and to control the machinery processes. Which that means it's gonna get operate or the oversee of operations from anywhere in the world. So by using these devices, they're gonna connect to the internet, which it has enhancing of flexibility and it allows the quicker responses to be of any quicker responses to be on any of issues even. And so, and coming to the monitoring and control, in the name itself, we come to know that it is all about the remote monitoring. So, it controls the machinery and the processes. So, yeah, it is all about means that these operations gonna be operations gonna be done in anywhere in the world even. So these IoT of an industry information is it has to be for a remote monitoring, Mr. has just mentioned now. And also it's gonna be better control of the machine and the processes. This means it's gonna be this operation is gonna be at anywhere in the world even. So by using this device, it's gonna connect the internet and it's gonna have the very flexibility among it, allowing of a quick responses of any issues. And the next thing was predictive maintenance. So coming to the predictive maintenance, this IoT can predict the potential effectiveness of a failures by controlling the monitoring and the condition and the performance of machinery. So this may leads to the some cost savings by allowing the planned maintenance and by avoiding unexpected time, downtime, etc., and by extending the life of equipment even. So the monitoring is in itself, the name itself, we come to that is a monitoring. So what it will really monitor? So these gonna monitor the controlling of a machinery and the processes. And these operations gonna be done anywhere by connecting to the network or which is the internet. So it has a very flexibility among by allowing the responses of any issues very quickly. Next thing was predictive maintenance. These predictive maintenance have been has a very potential by to predict the fair use of any monitoring condition and the performance of any ministry. So this leads to the cost savings by allowing the planned maintenance, etc. things, unexpected downtime, the lifetime equipment, etc. things. So next thing was application of an IoT of an industrial automation. So it has a six things, which is a manufacturing, agriculture, logistics and supply chain, and energy, automotive and healthcare. For the manufacturing. Okay. This manufacturing has a significant application of is in a very quality of a control and decisions. So in the past, this quality has been controlled often by involving some manual inspection and by time-consuming process, costly thing, and to be a human errors. But now, however, it has been rectified by manufacturing some enabling of a real-time automated quality of a control. These companies has been affected that production lines to be within a network with the sensors to monitor the process of in real time. So these sensors going to be collect the various data, which including some terms, which is temperature, pressure, vibration, visual information. The collected data is analyzed to detect the uh, deviations from the standard parameters that may indicate a quality issue. And as a result, it helps to be reduce the wastage of ensure the high quality and consistency in final products. So manufacturing is all about it is of a quality control and the assurance. So there was some misleading things happen in the previous of our times, but now it has been everything has been rectified and everything is automatically on controlling stage only. And it enables all the real time things. Next, the next thing is an IoT. The next thing was agriculture. So in these agriculture process, they have a fiction of a farming, as we know. These sensors gonna be used by to monitor the various factors of the soil moisture levels, crop growth, livestock health, and etc. Just like an example, if we take the John, the man, he is leading a agriculture with an missionary maker. So he has been a tractors to equipped with an IoT sensors, which is like a GPS and etc. things. So you can trace the everything data of the growth and the leaf structures and by capturing some live of the things. Even it's like 24 hours of time. Everything they want to collect and they want to store even the everyday data itself. So in that way, he come to know that whether the growth, the whole crop is growing without any bacteria or with the following of the steps or not. So in that way, in agriculture, farming things. So these things are going to be used to monitor the various factors like soil moisture levels, growth control, livestock health, etc. The next thing was logistics and supply chain. So these logistics are another field where this IoT is making significant of impact. So by taking these things as an example, THLS smart tracks, sorry, trucks. These offer like it is used for shipments and etc. things for goods and services. Sweeping these vehicles has been given is going to be tracked the real time to collect the data from the traffic conditions and to deliver the schedules, etc. things. So by doing this, so they can be able to optimize the route planning and this going to reduce the fuel consumption at the very time. And the end result going to be configured to the both efficiency and sustainability. Next thing was energy. So these energy sector plays a great role to create the smart grids. If we take any good example of an Italy, so this company has been developed at 30 millions of some smart meters to monitor and it has been optimized to some kind of energy consumption of a great way. So yeah, so it is all of a creating of an like, producing of some kind of an energy. So the basically smart grid is all about it is an electric grid which it involves some transmission lines and transporters for a traditional power grid in Norway. So it involves an IoT to that communicate the each other with the consumers. It's like an example smart meter and this is an automation and communication of an IoT of task systems. So basically, it can be get monitor the power flows of from the points of a generation to points of a consumption. The benefits of this is that it is a lowering of the bill costs and a better services of renewability, and it also improves the energy efficiency. And these automotive of these very extreme was an automotive. So in these the automotive, so these IoT is to be transformed the automotive by the manufacturing and the post production services. So example like Tesla, we have discussed, right? So coming to the Tesla, etc. So coming to the Tesla, then the Tesla has been implemented some automatic driving stage and self have a capability of some of application. So the remote they can also consider to maintenance and over the area of the software updates, etc. things. It has been implemented for every applications only, electric vehicles, etc. things. And the next thing was so even the electric vehicles has been integrated processes. The finding of it to be hard to find a smooth processes as they had some IC engines. The digital twins have been helping from them, like them to here. It's a picture of manufacturing. This is the last thing was in healthcare. So in these healthcare, they bring that remote patient monitoring, smart sensors, wearable devices, and also this enables the processing, the personalized care, and really they have been detected the personal potential of a health issues. The advantages of an IoT industrial automation is that I'm going to get to be enhanced of efficiency and productivity. And enhanced efficiency and productivity, and it has an improved quality control, increased safety, and the better decision. So, this is the first advantage of an automation of an IoT, which is enhanced efficiency and productivity. It helps to optimize the various industrial processes just by real-time monitoring and by the data analysis. So wherever you go, the IoT is mainly concentrates upon the sensors and applications and also the monitoring process. So it helps that what way? Yeah, automation. So it helps to optimize that the various industrial processes to by the enabling of real-time monitoring and the data analysis. Okay, it is all about the real-time monitoring and the data analysis, which it leads to be increasing of productivity and efficiency. Okay, the productivity means in the sense like the quality of the work and etc. The all the things when you start doing. So it's gonna be like these things they're gonna monitor and they get the data to be analysis as spontaneously. And the next thing was improved quality control. So it allows that the detailing tracking and analysis of production processes, and this ensures that high quality output and reduces the rate of a defect and the wastage. The next thing was increased safety. By monitoring the environmental conditions and detecting of hazards, these IoT enhances the workplace and safety by protecting the both employees and assets. So yeah, in the increased safety, the improved quality is all says that it's going to reduces the defects and the wastages. Okay. Coming to the increased safety, uh, coming to the increased safety, it's going to be detect the hazards and the environmental conditions they're going to maintain, they're going to monitor. And also it enhances the workplace of a safety by protecting the employees and assets. Okay. And the last thing was a decision better. Wait a minute. Not the last thing. Yeah. Yeah. The last thing of advantage is that the better decision making, wherever the field, wherever the sector is better Guys, please someone respond to me. Was it okay right now? I have gotten a network issue for some 2 minutes, I think. And someone please react with a hand emoji. Please. React fastly, right, guys? Okay.